everything we're about to do here is strictly two-dimensional. So suppose I have this two-dimensional region D, and it's bounded by a closed curve C. We do have two technicalities. So one is that the curve has to be simple, which means it doesn't intersect itself except where the end meets the beginning. And the other is that it's positively oriented, which means that if you imagine walking along the curve in the direction that's indicated, the region needs to be on your left. If you walked around the opposite way, the region would be on your right. So we always want the region on the left that's positively oriented. And then we have an important theorem known as Green's theorem. So Green's theorem says that the double integral over d of this quantity, dA, is a line integral of p dx plus q dy. And remember, we can always write an integral like that as field dot dr. Now for our purposes, the important thing here is that sometimes one side of this is a lot easier to evaluate than the other, so you can pass from one side to the other using this theorem. So an interesting case occurs if we can make this side here, if we can make this thing 1, then the left side is just the area of D. So one way of doing that is to let Q equal 1/2 x, P equal minus 1/2 y. Okay, so then that gives that Q sub x minus P sub y is equal to 1. So the left side just becomes the area of D. And then we write out the right-hand side. We get 1/2 x dy minus 1/2 y dx. And so if this integral happens to be easy for your region, then you have a very nice way of computing the area of that region.